All right, so today we're starting in on quadratic functions. So last year you worked with functions, but you worked with things like y equals 3x or f of x equals 7x minus 4. Basically, you had an x in your function, and your picture usually looked like a line. You know, if this was your coordinate plane, you worked with lines. This year, we're going to continue with functions. We're going to study a lot of the same things. But this year, our functions look like this. We call them quadratic functions. And the reason it's called a quadratic is because of that x squared right there. That makes it a quadratic. And what that does to your graph is instead of just having a line, we end up with something called a parabola. And it's shaped like a U, or if it's flipped upside down, an upside down U. But that's the basic shape of a quadratic function. And it's going to move around just like the line did, depending on what values are put into the function, depending on the equation and what it looks like. So dealing with quadratic functions, a lot of today's stuff, we're going to go through kind of quickly because it's review. And if you need to pause the video, go back, re-listen, re-watch, you can do so. But the first steps here on the notes, this first little bit of information at the top is just giving you instructions on how to graph these on your calculator. So I'm going to switch to my calculator screen, and it tells you that, let me clear this out for us. It says press y equals to type the function. So on your calculator, you have this y equals button. And then you just type in the function. We use this button right here for x, 2x squared plus 8x minus 1. So that's where I type in my function, right there next to the y equals. And when I hit graph, it's going to graph the picture for me. Sometimes because other people are using these calculators, if you get a weird window, in the notes there, it tells you to click on zoom. And then if you choose option 6, then it'll zoom and give you a nice window. Okay. The other thing that you need to know, so here's our basic graph right here. If I click second table, this option right here, my second graph gives me the table. And it gives me a list of all of the values on my graph. So it's saying that when x equals 1, y equals 9. So if I look at my graph, when x equals 1, which is right here, y equals 9, which is up here. So it gives you the points that are on this graph. Remember, that's what a function is. You put something in and you get something out. So when I'm looking at this function right here, I put a value in for x, and it gives me a output, a y value. Okay, so that's how we graph using the calculator. Now we're going to have to find some specific information about our graphs. There's things that we're interested in. One of those is if we have to find a specific coordinate, a specific point. For example, the function passes through the point. Remember, this is my x, this is my y, through the point 2 comma what. So it wants to know when x equals 2, what value is my y value? So if I look at my calculator, I can either go over to 2 and try to figure out what that y value is, or I can just go to my table. Second graph gives me my table, and I go down to 2, and it tells me that my y value is 23. So 2 comma 23 is a point on my graph. All right. Now the vertex, this is different than last year because lines don't have vertexes. This year, the vertex is the specific point. So it's going to be an XY coordinate. That's what I mean by a specific point. It is a point on the graph where the parabola changes direction. Okay, it's where the parabola changes direction. So looking at my picture, it's where my graph goes, my graph is going down, 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 down. And then right here, I get to the bottom and I switch and I start going up. So my vertex is going to be this point right here. And there's a couple of different ways we can find that. One of them is to use your eyeballs. Look at it. If I look at this picture, it looks like this point is at about -2 and down 9. So it looks like it's somewhere around -2, -9. That's one way to find the vertex. The other way to find the vertex is to trace the graph. If I hit the trace button, it gives me this little cursor, and as I scroll back and forth, it follows the graph. And what I can do is try to get close to that vertex. Sometimes, if you notice, it kind of skips numbers. But if I look at what it's around when I'm at the bottom, I'm at about -2, -9. So I'm guessing and analyzing, saying, you know what, the picture, it looks like it's about -2, -9. When I trace it, I'm at about -2, -9. So that's probably my vertex. Okay. Moving on. Now the axis of symmetry. Again, something new this year. But the two sides of a graph on opposite sides of the axis of symmetry look like mirror images of each other. So the two sides of a graph on opposite sides of the axis of symmetry look like mirror images of each other. In other words, when I look at my graph, I'm looking for a line that makes one side. That's not what I wanted. Well, that'll work. Never mind. So what I'm looking for is I'm looking for a line that splits my graph in half. I don't want my line going this way because I want both sides of my line to be the same. And the top and the bottom of this obviously are not the same. So what I'm looking for is the line that goes right down the middle. Do you like my nice straight line? I'm looking for this line right here. This is called the axis of symmetry. It goes straight up and down. It's a line. And the left side of my graph looks exactly like the right side. It's a mirror image. So what I need to do to answer this question is my answer is going to be a line. So it has to be x equals something. So if I look at my graph, that line right here, x is always the same because it goes straight up and down. X is always 1, 2 to the left. Doesn't matter if I'm up here or here or here. Wherever I am on that line that went straight up and down, x is always going to equal -2. So that's my axis of symmetry. X equals -2. So your answer is going to be a line, and it goes through the vertex. It's a line that goes through the vertex. And the hint I'm going to give you is that you use the x value of your vertex. Remember, my vertex was at -2, -9. That -2 gives me my axis of symmetry. Okay. Next thing, Y-intercept. This you should be familiar with. The Y-intercept is the point of the graph that crosses the y-axis. So it's a point on the graph where my picture crosses the y-axis, which means that x is going to equal 0. So going back to our graph right here, I'm looking for the point where remember, this is my y-axis right here. And I'm looking for the point where we cross that y-axis right here. Well, I should be careful because it looks like it crosses right there. In fact, I marked that a little bit high because if you can tell, there's still some blue over here. I might be a little bit lower than that. But Either way, we're looking for where we cross that y-axis, which means that the y-axis, my x value, is 0 at that point. So the easiest way to find your y-intercept is to go to your graph, go to the table, and find when x equals 0, what does y equal? -1. So when x is 0, y is going to be -1. That's my y-intercept. Now the x-intercept are the points where the graph crosses the x-axis. That's when y is equal to 0. And with the x, notice it says x-intercepts because a lot of times there's actually 2 of them. Because my shape is a U, there's a chance for it to cross the y-axis, the x-axis twice in 2 different places. So we could possibly have 2 x-intercepts. And if I go to my graph, if I look at my picture, I'm crossing, let's get on this screen right here. I'm crossing right about here and right about here. So I'm going to approximate and say that's a little bit, that's not 1, that's not 0. It's a little bit bigger than 0. And this one is a little bit bigger than -4. So my approximations, I'm going to say it's about -4.1, 0, and at about, I don't know, 0.25, 0. Again, I'm just estimating. That's about a quarter of the way. That's just a little bit past -4. So I'm going to estimate that that's about where my x-intercepts are. In the next unit, next quarter, we're going to actually find these exact numbers, these values. But for now, we're just going to approximate. The other way to do that is to trace. You can trace and just get close to your intercepts. And just say, okay, so I'm at about, yeah, I'm almost at -4.10. And then my other one, when I trace it, I'm a little bit bigger than 0. Whoops, I went too far. I'm a little bit bigger than 0 when my y value is 0. All right. Okay, moving on. The next thing that we need to review is domain. So remember, domain is the domain of a function, I guess, are all the possible inputs or values of x. So it's all of the different things that I can plug into x. Technically, in the math world, we say that it's all the possible values of the independent variable. So when I'm looking at my picture, all of the different values that can go in for x. One of the ways to find that is just looking at the graph. What happens with my x's? Remember, the domain are the x values. So going left and right, or right and left, what happens to my x's? Now, as I'm going to the right here, my picture cuts off, but my parabola keeps going further and further and further to the right, and it keeps going further and further and further to the left. And it's going to get steeper and steeper, but it can go as far this way as we want and as far to the left as we want. I can plug, looking at my function right here, I can plug anything I want in for x. So for the most part, when we're dealing with quadratics, not always, but most of the time, usually your answer is going to be a range that goes from -infinity up to infinity. Now, this isn't a point. This is a range of numbers. This says that starting from -infinity, it includes all of the numbers up to infinity. So basically, I can put all numbers in for x. That's my domain. Okay. Now, the range of a function is all of the possible outputs. All of the possible outputs or values of y. And that's the key right there. What are all the different values of y? When I look at my picture, My y values get bigger, 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 bigger on this side, get bigger, 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 bigger here, but they don't ever go below that line right there. They don't ever go down below the vertex. And that's going to be our hint, is we're looking at the y value of the vertex, because that is the lowest point. That's the lowest y value that I can get to. I can't go any lower than this. There's nothing down here on my graph. And so the way that we write our answer is as an inequality, because y is going to be any number bigger than that value of my vertex, this value right here. Y is going to be everything bigger than -9. It's going to keep going up from -9. So y is greater than or equal to -9. Those are all the possible outputs for my dependent variable. All right. Now, what if you don't have a calculator? In fact, even with a calculator, some of the homework today you're going to have to do without. So in general, a quadratic function looks like this. Something x squared, and whatever's in front of it, we call a. And sometimes we have a number with an x, and we call that b. And then c would be the number all by itself, the constant. So in our example, f of x equals -x squared plus 4x plus 3. My a is right there, -1. My b is right here, it's 4. And c is that constant right there, 3. All right. So f of x equals -x squared plus 4x plus 3. And remember, that's just like saying y equals these things. So what we need to do to graph this, just like graphing the lines that you did last year, we have to make a list of x and y values that are on the graph. We want to start with the vertex. Last year, it didn't really matter what you started with. You picked nice numbers. This year, we need to start with the vertex. And in order to find the vertex, we don't know what it looks like. We don't have the picture. So in order to find the vertex, first things first, if you have a calculator, plug it in, find the vertex that way. But we can also find it without a vertex. And the way that we do that is first we find the x value that we need. And the x value of the vertex uses this formula. The x value is going to be -b divided by 2a. So using my numbers here, that means that my x value is going to be -4 divided by 2 multiplied by -1, 2 times a. So -4 divided by -2 is just 2. So that means my vertex x value is 2. To figure out the y value, I just plug 2 into my function. So -2 squared plus 4 times 2 plus 3. So that's -4 plus 8 plus 3. -4 plus 8 is 4, plus 3 is 7. So my y value is 7. So on my graph, and I think I gave you a picture here, I did. So 1, 2, 3, 4, 5, 6, 7. My vertex is right here. Okay, that's where I start. Then it tells us to choose x values around the vertex as necessary. Solve the equation to find the y value. So if my x value of my vertex is 2. So I want to pick a number around 2. In fact, I want to pick 1 to the left and 1 to the right because parabolas are symmetrical around that vertex. So an easy x value to the left right here is going to be x equals 0. So when x equals 0, I want to know what does y equal. So I take my function, -x squared plus 4x plus 3, and I plug 0 into it. negative 0 squared plus 4 times 0 plus 3. That's gone, that's gone. All I'm left with is 3. So one of the points on my graph is 0, 3. So I go over 0 and I go up 1, 2, 3. Now I want to find a point on this side of the vertex. So I'm going to go over to, let's go over to 5. So let's say when x equals 5. So plug that into our equation. Negative 5 squared plus 4 times 5 plus 3. This is negative 25 plus 20 plus 3 is going to be negative 2. So at 5, my y value is negative 2. So I go over 1, 2, 3, 4, 5, and I go down 2. So those are 2 points on my graph. Now I plot the points and connect them to finish the picture. So from my vertex, I'm going to connect this one. And from my vertex, I'm going to connect through this one right here. Okay? And that's as fancy as it needs to look. All right. Now that we have our picture, we may have to plug in extra values for x to find points. So the function passes through the point 4 comma what? Well, remember our function was negative x squared plus 4x plus 3. So I have to plug in a 4 and see what I get. So negative 4 squared plus 4 times 4 plus 3 is negative 16 plus 16 plus 3. Those are going to cancel, and all I'm left with is 3. So one of my points is 4 comma 3. Where is the vertex? Well, the nice thing is we already found the vertex. It was this point right here, so 2, 7. So my vertex is 2, 7. What is the axis of symmetry? Well, to do the axis of symmetry, remember, we only need the x value of our vertex. So my x value is 2. So my axis of symmetry is x equals 2. Find the y-intercept. Remember, plug 0 in for x, which we already did. Remember, it was negative 0 squared plus 4 times 0 plus 3. And all we were left with is the 3. So my y-intercept is 0 comma 3. Use the graph to estimate the x-intercepts. So now I'm looking for where it crosses the x-axis, which means my y value is going to be 0. So looking back at my picture, I cross at about this point and at about this point. And we're just going to take a guess. So this is 1, 2, 3, 4, not quite 5. And this is a little bit more than negative 1. So I'm going to go back and I'm going to say, oh, we're on the next page. We're going to say a little bit bigger than negative 1, so maybe negative 1.2, and a little bit smaller than 5, so maybe 4.8. Not a lot smaller, but it was a little bit smaller. And remember, I'm approximating. So as long as I'm close, I should be good. Okay? A couple more questions about my graph. What is the domain? So looking at my graph, going to the left and the right, my x values. Well, it goes to the left forever, and it goes to the right forever. So my domain is negative infinity to infinity. What is the range? Remember, your range are the y values, and the hint was to use the y value from the vertex. So y and my y value for my vertex, my y value was 7, but my picture goes down. So y, all of my points on my graph are below 7. So y is going to actually be less than or equal to 7. It never is bigger than 7. So it has to be less than or equal to it. Okay, as far as the last bit of notes, This last page is, I'm not going to go through it with you. It tells you how to come up with a line of fit. It's kind of like you found the line of best fit last year. This year, you're going to find the parabola of best fit is kind of what we call it. And there's just some instructions here of how to do that on your calculator. So on the homework, I think number 10 and number 11 are going to use this information right here. So just follow these steps and it'll help you through the process to do numbers 10 and 11. If you have any questions, come and see me. But you should be working on homework number 6 today. It's due next time, so it's going to be due on Monday. Make sure you get it done, be prepared for class, and good luck.